The triangle today and talk about the angle measures. Let me ask you right off the bat. I know most of you know how many degrees in every triangle. Okay, you've known that for a while, right? Let's actually put a name to it now. It's called the triangle angle sum theorem. All right, that in a triangle, all interior angles add to 180. Okay, we're going to refer to that as the triangle angle sum theorem now. Give it a name. And notice I said interior because later on today we're going to talk about the exterior angles of a triangle and how they're formed and what they add up to. Okay, so question one, just a pretty basic one. So go ahead, get a diagram set up, draw yourself a triangle, and go ahead and label those angles 2x, x plus 10, and 3x plus 10. Or if you don't want a diagram, that's fine too. 2x, x plus 10, and 3x minus. Is that minus for you guys? Okay, fade sometime on the board. 3x minus 10. And we're solving for x. This is not going to go anywhere though. Okay, equation I can solve. Who has 13? Go ahead, equation I can set up and solve for x. Equal to? Why are those two angles equal?
Oh,
plus x plus 10 plus 2x. They all add up to 180. All right, let's solve it. Getting out x equals 30. Perfect. Let's go to part B now. Find the degree measures of each of those angles now. So take your value of x, which was hopefully 30, and plug it back into each angle, and I'll ask somebody in a second what all three angles are. All three angle measurements. What are we looking at here? Who's got 4?
40.
Yep.
60.
Got it.
And 80.
Okay. So I got 3 angles of 60, 40, 80. Guys, if you need to look back in your notes from Monday, name this triangle based on those 3 angles. Based on the angle measures, not this. We don't know anything about the sides. Angle measures only. There's only certain ways we can name a triangle based on its angles. So go ahead and take a look back. I got angles of 60, 40, and 80, meaning I can call this triangle based on the angles what? 4 again, Rachel? Obtuse is when one angle is bigger than 90. Do I have one angle bigger than 90 up here? No, I have all 3 angles that are less than 90, so this is acute triangle, yep. And we're going to write more than just acute here. Let's get used to backing ourselves up. How do I know it's acute? One more time. How do I know it's acute? Who's got 2? Okay, all 3 angles are less than 90. What you said, Will, is fine as well. Any questions? Now let's start introducing some of the Unit 1 and Unit 2 vocab into here. All right, no diagram drawn, so we're going to have to draw our own triangle ABC. So go ahead, set up triangle ABC. Doesn't matter where you put A, B, and C. Probably should take it. Okay, triangle ABC, label the angles here for me, 40 and 30. Do we just want to answer part A right now? Find angle B? Let's just answer it right now. We'll put it in, and then we'll read the rest of the problem. So angle B, what do you got for me? Angle B. We're looking at, who's got, oh, Rachel, back to you. 110. Okay, and again, guys, I want to make sure we're good with the vocabulary. How'd you know it was 110? Okay, I don't want to write all that long stuff she just said.
Oh, this triangle angle something.
There you go. I can now just refer to it as the triangle angle sum theorem. And theorem, guys, you can just abbreviate THM for me. Right? The triangle angle sum theorem. Okay, let's read the rest of the problem. Everyone go ahead, draw in line segment CD. Line segment CD, where D is a point on AB. Line segment CD. D is some point on AB. And what's CD doing to angle C? Bisecting it, yes. Meaning what? What do we know about bisector? I'm going to harp on, oh, you're good, Rachel. 5. Who's got 5? Mike, hi. What's a bisector do to an angle?
Creates congruent sides.
Oh, angle. So go ahead here. Answer the next question for me then, Mike. What's ACD? A, follow the letters, everyone, because I know we still get confused with this. ACD. This angle right here is going to be what? 15. And how'd you know it was going to be 15 so you can back yourself up? Love it. Definition of a bisector. Everyone good on how we knew it was 15? Where angle ACD is? I still get nervous with some of you guys finding certain angles. We ready for part C? ADC. Find that angle right now. A to D to C. How can I find how large that angle is? A to D to C. So again, this angle right here, what's its measure? How'd you find it? Let's do this. 13? 13, anybody? Would not be. Here's a triangle right there, right? ADC. Don't I know 2 of the angles already? 40 and 15? 40 and 15, right? And how many degrees on every triangle? 180. So if I already have 40 and 15, the third angle will be 145? 25, yep. What do we use once again? The triangle angle sum theorem. There's 125, got it? Everyone all good? Ready for the last part? BDC, find that angle, find BDC for me, and then try to find out what it is. B to D to C. Nine?
It's 55.
It is 55. Now, I'm going to ask Justin how he found it, but there's actually 2 different ways he could have found it. And when I want to talk about both ways, but how'd you find it?
I did 180 minus 125.
So you did that these 2 were, give me a nice name for them.
Supplementary. Or linear pairs.
Yep, so he did linear pairs are supplementary. That's one way. Anybody find it a different way? Because maybe you didn't see the linear pairs right away. Go ahead, Amy. Yep. There you go. These 2 were 110 and 15 already from previous part of the problem. So angle sum theorem says they had the 180. Nice job, everybody. Questions? All right, let's keep moving before you guys aren't ready for exterior angles yet. I need to do one more interior angle problem with you. Okay, same thing, triangle ABC. Set this bad boy up. A and B, a ratio of 2 to 7. I'll get back to that in a second. Angle C, 72 degrees. Perfect. Beautiful. What do you want to do with that 2 and 7? We've been doing something with two numbers in a ratio all year long, how to put them into a diagram, how to put them into an equation. What have we been doing with numbers in a ratio this year? Putting what with them? 12? Put x's with them. So angle A is not going to be 2. That doesn't make any sense. 2 degrees, it's going to be 2x. And angle B won't be 7 degrees. It'll be 7x. And now what can I do with all three of those? Here we go. 6. What can I do with all three of those? All right, let's do it. 2x plus 7x plus 72. Grand total of 180. Go ahead, kiddos. Solve it up. Hi.
Could you do, like, I subtracted 72 from 180, so then could you do...
Which is about what your classmates are about to do in about 30 seconds. But yeah, that's fine.
Can you do that before? And then
Sure.
do 2x?
Sure. And we're getting out x equals 12. Hopefully. And then it said, make sure, I can't say anything because Cameron hasn't taken it, but a couple of you guys did not read the questions yesterday. You thought x was done and you were done. All right, you did not plug it back in and answer the question. Find the measure of each angle. All right, well, I already know A, I already know C, so angle A and angle B. Looks like I got to do 2 times 12 and 7 times 12. So the other two angles, what are we looking at? 18, what are we looking at for the two other angles?
B equals 84 and A equals 24.
There we go. Anything about the inside here? 180 degrees, anything about the inside angles before we go on the outside of the triangle? Okay, that probably wasn't too bad for many of you. But let's get to the outside of a triangle. Right? I know you don't have a separate triangle drawn next to it, but we'll draw that one in a second, but not right now. Okay, exterior, meaning I'm going outside, just like the parallel lines. I'm going outside. Exterior angles of a triangle, how are they formed? Basically, look, guys, I take one side of the triangle and extend it. You make an exterior angle. So angle 1 in this case is one of the exterior angles of that triangle I've created. Now, let's talk about how it relates to the angles inside. Every exterior has an adjacent interior, meaning the one right next to it, the one that it shares a vertex with, the one that it shares a common side with. So if angle 1 is my exterior, what's my adjacent interior to it? Angle lowercase a, yes. So that's very easy to find because it's the one right next to it. The other two in the triangle, the ones that are not adjacent but still inside the triangle, you can refer to them one of two ways. Non-adjacent interior angles. That's clever, huh? I'll be referring to them, though, as the remote interior angles. Those are the two angles inside the triangle that are not adjacent to the exterior angle. In our case, for angle 1, what are the remote interiors? What are the other two inside that are not next to it? B and C. Okay, I have more exterior angles up there, though, and I want to keep using this vocab, so here we go. Need somebody's help here. Here we go. 2. Name another exterior angle. Angle 3. All right, going out of order. I love it. What's its adjacent interior, Will, to angle 3? Lowercase c. And what are the other two, the remote interiors that are not next to it? Angle A and B. And we have one more exterior angle up there we did not talk about. 10. 2. Angle 2. What's the angle next to it inside?
B.
Angle B, lowercase b. And what about the remote interiors, the other two inside that are not next to angle 2? A and C. Whoa, we're not going anywhere. We're not going anywhere. We still got a huge theorem here we got to talk about. And that is, how do these guys relate to some of these here? Okay, and you're going to find out right now. So go ahead now, draw your triangle next to the one I gave you. And make 3 exterior angles. Okay, make 3 exterior angles. So just pick a side, extend it. Pick a side, extend it. Pick a third side, extend it. And I'm going to need somebody's help real quick. Who's got 17? Okay, Max, need your help. You pick the angles for inside the triangle. Remember, they got to add to 180. And don't give me any two that are the same. Okay, 40, 60, and 80. But fine with that. Can you guys find each angle's exterior angle? Like at 80, what's going to be the exterior angle? Well, what do you know about these two? What do they look like? They're linear pairs. Linear pairs are supplementary. So what's next to the 80? 100 degrees. Yep. What's going to be the exterior angle at 40? 140. And then at 60, 120. Some of you may not see this. That's fine. Nobody may see this, and this is fine. But can you find any patterns up on that triangle? Can you find any patterns up on that triangle? Anybody want to see any? Want to give us? Think they have it? Good, Karen, sure. If you're wrong, who cares?
Every number goes up by 20, so it's like 40 plus. Yeah. Okay, it's like 40 plus 20 is 50, plus 20 is 80, plus 20 is 100, 120, 140. I don't know if that's just.
Okay, I think it's just with those numbers because Max could have gave me anything that adds to 180. So I think it's just with those particular numbers, but that is true. That is not what I was looking for, but it's true. Okay, here it is. Ready? Everybody, somebody pick an exterior angle for me. 100. Everyone see 100? Name the two angles that are remote interior to 100 degrees. 60 and 40. Somebody name another exterior angle up there. 120. Name the two remote interior angles for 120. Oh, what are you telling me now? That the exterior angle is equal to the remote interiors added up. Is that what? That's basically what you're. Does that work for the final one too? Does 140 equal 60 plus 80? Okay, so you guys just found the theorem. All right, which says the following: an exterior angle of a triangle. It's got to be of a triangle because anything bigger sided than anything has more sides than a triangle, it won't work. Any exterior angle of a triangle is equal to the, what do I call it when I add two numbers up? Equal to the, Nick on top of it, equal to the sum of its, what do I call those angles again? Remote interior angles. And what do you think this theorem is called? What was the theorem today at the beginning of class called? Triangle. So this is the triangle exterior angle theorem. If you want to just shorthand it so you don't have to write all this every time. Okay. All right, let's see if you picked it up or not. Here we go. Find the number of degrees in x, in angle x. Angle x, inside or outside? Outside. So it should be an exterior angle, which is equal to the sum of, what's the measure of its remote interiors? 40 and 90. So angle x will be 130 degrees. Now, I realize, I get it. Maybe you don't want to do it like that. Maybe you want to find this angle and then say it's supplementary to x. That's fine. That's fine. But I'm going to let you know you're going to have to remember this theorem sooner or later, and that sooner or later is right now in example 2. I got this problem right off an old Regents exam, similar to what you'll be taking in June. All right, so go ahead, label your angles. Angle A, angle B, angle ACD. I know some of you are getting nervous already because you see an x squared. I would be getting nervous too. X squared minus 6x. Angle B is 2x minus 3. Everyone see where ACD is? That's an exterior angle I'm giving you there, ACD. Make sure we label it correctly, ACD. Are we ready to go to work here? I'm nervous about this one. Need some help though. 6. What's the exterior angle in this diagram? Okay, and I know an exterior angle from the theorem I just went over, you guys, is equal to, what's that 9x plus 27 equal to? Which would be what in this case? Okay, half the battle has been won. Is everybody good? Exterior angle is equal to the remote interiors added up. Okay, here we go. Digging deep in the old time machine from last year. I got a squared up here. Does that signal what you're going to have to do eventually? Eventually what I'm going to have to do here. Ooh, no, not square root. If I just had an x squared and nothing else, I'd probably yeah, you're right. If I got rid of these, but now I got an x squared and an x here too. So sooner or later, I'm going to have to, starts with an F, ends in actor. Good job. Yeah, we're going to have to factor here sooner or later. X squared and x. Okay, well, first of all, forget factoring. We're not even at that point yet. You can't do that unless, anybody remember about your equation last year? You cannot factor anything unless it's equal to 0. So we need to get one side equal to 0. Hey, this is how it's going to be this year. All right, there's algebra topics that still stick. What I would recommend is keeping the x squared positive, which it already is. So help me move the 9x and the 27 over right now. Actually, you know what? We should probably clean up that right side first, huh? So let's do that. Clean up the right side for me. What do I have? X squared minus 4x. Okay, so I clean that up before I move anything over. How do I move the 9x over? Subtract it. How do I move the 27 over? Okay, go right ahead. X squared. What's, you got negative 4x minus 9x. Negative 13x. Negative 3 minus 27. Negative 30. All right, let's do, hey, here we go. We're not shying away from it. Again, this was an old Regents question. Here we go. I prefer not to use quadratic formula here, considering the number out in front is 1. Anybody remember the game you're trying to play? 2 numbers that multiply to 30, so yes, factors. So multiply to 30, but negative 30, but have to add to negative 13. So let's start thinking about numbers that multiply to 30 first. That could possibly give me negative 13. I'm hearing 2 sets of answers right now, which I expected. I'm hearing 10 and 3, and I'm hearing 15 and 2. Because both pairs give you a 13 somehow. But only one pair is going to work when you put signs in front of it. X and X. Think about it. What is the only pair that's going to work that's going to add to negative 13 and at the same time multiply to negative 30? That's the key. They got to add to negative 13, multiply to negative 30. Which pair is it going to be? Dun, dun, dun. Let's do this. 17. Okay, Max is correct. It is 15 and 2. What signs do I need to put in front? It needs to add to negative 13. Good, Hugh.
Subtraction with 15 in addition.
Why didn't the 10 and 3 work? Well, quickly, you could make them add to negative 13, right? But you can't make, what's that multiply to? Yeah, positive. So that's why that didn't work. All right, still, can we get a final answer now? I have two answers. X equals, okay, x equals negative 2 over here. And x equals positive 15. Are we okay on how we got that? No? You set it equal? X minus 15 and solve for x. X equals x plus 2, solve for x.
You always like flip the sign.
As long as it's 1x. If it was like 3x, then I'd have to actually set it equal to 0 and move everything over. Yeah. Okay, there are the two answers. Or do I have two answers? Here's the problem. Ready? Everybody right now, take negative 2 and plug it in for angle B. Tell me what the problem is. Take negative 2 for x, plug it into angle B. Anybody see a problem? What's the problem? It's a negative angle? Are you kidding me? We don't, not until next year for you guys. All right, for this year, that doesn't fly with us. Okay, so what we need to do, story of some of your lives, is reject that answer. Okay, too harsh?
No, that's pretty good.
Too harsh?
Pretty good.
Reject that one. Now, again, hey, all kidding aside, I am not rejecting it because it's a negative 2. I'm rejecting it because when I plugged it in, what did I get? A negative angle, which is a no-go. Okay, so don't just assume you're crossing off a negative answer. Plug it in and see if you get a negative degree back. If you do, eliminate it. Okay? Everyone all right? Because watch, if you plug negative 2 in for the exterior angle, it's still going to be positive, and that's okay. But it's not going to be positive here. It'll be negative. So that's why I ended up rejecting it. Whew, how about that one, huh? Questions? All right. Yeah, we'll have enough time. Okay, here we go. Let's keep working with the exterior angles then. Triangle PQR. P is twice the measure of Q. What do you want to write down now? P, don't say anything. P is twice the measure of Q. What do you want to write down for that one? Who's got 9? P and Q, what can I write there? If P is twice the measure of Q.
For P, it's 2x.
Yep.
And for Q, it's x.
Nice job. Okay, twice the measure. And what do I got? An exterior angle at where? Where do I have the exterior angle? What do we have? Pirates in here? All right, going on. You guys fall for it every time. Fall for it every time. 120. Got an equation you can set up now for me? What's the equation? 13. What's the equation here?
2x plus x equals 1.
Exterior angle is equal to the sum of the two remote interiors. There it is. Some of you guys got to get over this hump. Make sure you solve for what is being asked. What are we looking for? Angle Q. What did we label as angle Q? Okay, so now we're done. Yes. Oh, thought we were done with all that parallel line business, huh? Thought we were done. You guys have to learn quick that just because we're done with the unit doesn't mean we're done forever. Everything still comes back. All right, I got parallel lines AB and CD. So maybe there's special types of angles formed there. Who knows? PQR and QS are drawn in. Yep. Angle X, 44. And angle Y, 98. Got it. So I got parallel lines, and I got myself a triangle here that maybe I can work with sooner or later. QRS, look for that angle right now on the diagram. QRS, everyone see the angle we're looking for. This one right here, QRS. There's the angle right there. Looking for its measure right now. The measure of QRS. And remember, I gave you parallel lines, and I gave you a triangle maybe to work with. There's something there that you can use. Something there that you can use. Oh, look what's connecting these parallel lines. PR, also known as a, oh, okay, now we're moving. Now we're moving. Emily, you want to add on here?
QRS is
44. Why? Because it's what with the original 44? Yes, and if the lines are parallel, what do we know? There you go. Parallel lines imply alternate interior angles congruent. Nice job. Okay, let's keep rolling here. RQS, everyone identify RQS for me. QRS, everyone see RQS. Everyone see that angle right here now. I think you have enough info to find it. Thanks for the confirmation. 11. Something, right? Equals what? Good. Everyone see what Emily's using? The exterior angle theorem. 98 is an exterior angle for this triangle. So it's equal to 44 plus the angle I'm finding. Right? So what do we got there? So what she's saying, 98 equals 44 plus angle RQS. Yep. And that angle will be, not off the hook yet, Emily. So move the 44 over. Yep, 54. And Emily just used what there? The triangle exterior angle theorem. And then how about Z now? Angle Z. Let me just write into that we found this one was 54. And then how about Z now? Z. What are we doing to find Z to wrap this up? 3?
We're going to subtract 4 from 180 to get 1.6.
And why did you do that, Sean?
Linear pairs are supplementary.
Good man. Linear pairs are supplementary. Perfect. Any questions from you guys? Questions, concerns? Okay. I know you're missing them because we haven't done them in 2 days, but we're going back to proofs tomorrow, yes. Yeah, I know you missed them.
Great job.